Now let us go for number 10 part B. Number 10 part B is telling us that we show that the points D is negative to 0, E is a half and 1.5, F is 3.5, then comma minus 3.5. So these are the points. So they want us to show that these points are vertices. So these points are vertices. They want us to show that these ones are vertices of a right angled triangle. Now you should know what a right angled triangle is. So a right angled triangle should be like this. So it means we should be having some 90 degrees somewhere. So it means if these ones are vertices, we can have D here, we can have E here, we can have F here. Okay? So if this one is a right angle, it means that for you to show that these ones are vertices of a right angle triangle, it means the slope of any two of the lines should be showing us that they are perpendicular. Remember, when we want to know that these lines are perpendicular, okay, the product of their gradient, if this one is gradient 1 times gradient 2, should be equal negative 1. So it means at any time when we get the slope of df, times the slope of de, it should be giving us negative 1. When it gives us negative 1, then we shall conclude and say that these points are vertices of a right angled triangle, because the slope they are making for the lines, they are showing us that they are perpendicular. And then being perpendicular, it means they are forming a right angled triangle. So I hope you're getting me. So we shall get the slope of each of the lines. We shall get the slope of DE, we get the slope of DF, and we also get a slope of FE. So you can ask yourself, why should we get the slope of FE when it is not perpendicular? Because remember, here they have not demarcated for us the triangle that this one is going to be. Someone can also label like this. Can label like F D E. Yes. So that's why I'm insisting that you have to find FE. So you might find FE, then FD. They are the ones making us the conclusion that it is a negative 1, or it is a right angle. Not this one, not DE and DF. So we should find the slope of each. DE, DF, FE. So we should find the slope of each. So we start by finding the slope or the gradient. So when you begin with DE, so gradient of DE. Remember, gradient is equal to what? Change in y over change in what? Over change in x. So it means it is y2 minus y1 out of x2 minus x1. Okay? This one will be giving me what? You have the points up there. So if this one is DE, then this one is x1, y1, this is x2, y2. So I come and substitute in here for me to get the values. So for me to get the values, so for y2 it is 1.5. It is 1.5 minus y1 which is 0 out of x2. X2 is a half minus x1 which is negative 2. So minus 2. What will be the answer? You have to put in a calculator and get the answer. Okay. Now it means up here 1.5, which is 1.5, of course minus 0, it remains this one. Then out of, now we have a half minus 2. This one is the same as a half plus 2. That one gives you 2.5. And then what is the answer? It is giving me 0.6 as the answer. So 0.6 is the answer. For gradient of what? Gradient of we have finished DE, so we can get EF or FE. So when you say gradient of EF, so you have the points E and F, not so? E, F. So when I have EF, this one will be x1, y1, x2, y2. So when I get the slope here, my y2 will be, this is minus. So minus 3.5, I have minus 0.5, not so? Minus, then y1 is here, 1.5, minus 1.5 out of, now x2 here is 3.5, then minus x1 here, I see it is 1.5, minus 1.5. So what is the answer? So up it gives us minus 5, which is minus 3.5 minus 1.5. Then out of, what about down? Down it gives us what? Down it might give us oh, I have made a mistake. This one was x2, which is this one, 3.5. Then x1, it is a half is 0.5. So this one will be giving me 3, and then giving me in points will be something like negative 1.67. I think it's the one after rounding off to 2 decimal places. Now there we go, we have the gradient of EF. Now we can get the gradient of FD or DF. So gradient of DF still the same, it will be equal to what? So I have D, I have F. This one can remain as x1, y1. Can remain as x1, y1. Then this one can remain as x2, y2. So when I substitute in here, I'll be having something like where is y2? Y2 is there. It is there. So this is minus 3.5, then minus y1, which is 0. I put 0 here. Then out of, you see, out of what? X2, which is 3.5. So 3.5, which is 3.5. That's so. Then minus, this is minus 2, isn't it? Minus 2. So this one will be giving me what? Up it is minus 3.5. Of course, minus 3.5 minus 0, you get minus 3.5 out of 3.5 plus 2, which gives you 5.5. Then what is the answer? So this one will be giving us something like negative 0.64 when you round off to 2 decimal places here. Okay, so there we are with the gradient of all. So you have seen the gradient of this one, of DF, is this one. Then the gradient, so we have seen that the gradient, let me write them here so that you can see them well. The gradient of DE, it was 0.6. Then the gradient of what? EF, the gradient of EF, it was giving us what? It was giving us negative 1.67. Then the gradient of DF, it was giving us negative, I'm losing the focus, oh my god. So the gradient of the gradient of DF is negative 0.64. Yes, so there we are. So do you think that when we multiply n of these, is there anything that will give us negative 1, because remember these ones are all gradients, so you can call this one m1, m2, any. So if I multiply this one times this one, can it give us a negative 1? I think no. When I multiply this and this, is there anything that can give us a negative 1? When I multiply this and this, I think nothing. Okay, so it means that these points do not form a what? They do not form, or they are not vertices of a right angled triangle. So it means they are not what? They are not vertices of a right angled triangle, because these ones, there is no any slope that we can multiply and then we get the product as negative 1. But if it was the case that when you get the slope here, like here becomes like negative 1, then here becomes 1, and then we get negative 1 times 1, we get negative 1. So of course this one will be our m1, m2, which is equal to negative 1. Then we would say that these points are vertices of a right angled triangle. Well, according to the answers we have got, when you multiply any of these slopes, there is no any slope, or there is no any combination of two slopes that can give us a negative 1. And there we can conclude and say that these points D, E, and F, they do not form what we call a right angled triangle. And then there is also a part that I was asking for, finding the shortest side. So finding the shortest side, now you come here, our right angled triangle is always like this. Okay, we have the adjacent here, we have, okay, if this one is the angle, we have the opposite here, we have the adjacent and the hypotenuse, isn't it? So the hypotenuse is always the longer side. Okay, it is always the longest of the three, and then remaining these two. So you know we have been looking for distances. So to know the shortest side, it means we have to look for the distance df and also look for distance de. Then you will see the one which is less than the other. So the one that is less than the other on de and the df, that one will be giving us the shortest what? Distance. Okay. Or I think that one. Okay, to avoid the confusion, remember, like I said, someone can draw a triangle like this, name it like this, and also another one, name it like this. So this method can somewhere lead you to a wrong answer. To a wrong answer. So now it means what you will have to do is you will have to find for all the distances. You get a distance DE, you get a distance DF, we also get the distance FE. Then you compare and see which one is the shortest distance. And then you answer the question. And they say that the shortest side is either DE or FE, then FD. I've said don't use the one I've told you at first, that you compare only these two. Because remember, I also told you that someone can name the triangle differently like this. So you might find that EF is the shortest, yet for you named it like in your own way and you made this one the longest side. So it's better we find the distances, all the three. DE, you know how to find distance using the other formula, also here, also here. Then the one which will be having the shortest what? Distance will be the shortest side. Yeah. So that's how we can do that number. So number 10 is done. We have done part A and part B. So you try you try those numbers yourself, by yourself, and you see what you will get. You will be comparing with mine. The good thing, you now have the videos, so you will be going back, you pause and see and rewind.